Hello everyone. Hi. We shall discuss about the very basic and important component of Hadoop, that is HDFS. Before moving further, I'll just give an introduction. I'd like to just share with you what exactly Hadoop is, why we require Hadoop, and all other things. Then I'll just move on further. What exactly Hadoop is? Initially, I'd like to start this journey sharing you what exactly Hadoop is, why we require Hadoop, what are all the problems that we have with the existing storage and processing methodologies. Before just moving to this, I'm sure that perhaps majority of the people have some conceptions thinking that whether Hadoop is a database or Hadoop is not only for storing but also for processing. Is Hadoop suit everywhere? Are there any situations where Hadoop doesn't suit? I'm sure these are all, and these will be all the questions that keeps on tricking the people. And let me just move on now. So before moving into this journey, let me start this with a simple example. Let's say that we opened a bank account somewhere in 2000. 14 years later, that is in 2014, we approached the bank and we asked them for the past 3 months bank statements. Where 3 months bank statements you can expect in the span of half an hour or 1 hour. Not a big deal. 10 years later, you approached the same bank and you asked them for the past 10 years bank statements. 3 months bank statements you can expect in the span of half an hour or 1 hour or at most of 2 hours. But what about the 10 years bank statements? Where the 10 years bank statements you cannot expect in the span of half an hour or 1 hour. Definitely it is not possible, because we know that the data will be moved to the backend, stored in huge magnitudes, in Teradata, NetAsia, moving on further with ETL, and then with data warehouse, generating reports, and this is the exact flow that usually happens by. I'm sure every one of us is aware of that. So we shall talk about existing storage and processing methodologies, and then let's talk about how Hadoop will be an alternative in handling those drawbacks in an excellent way, and how it can handle the so-called big data. So let's talk about data storage and data processing literature survey, where we shall talk about initially the existing storage and processing methodologies that are being opted for handling the data sets. Here I classify the data as people's major sources where we get data sets from. Usually machines like organizations like Google, Yahoo, Amazon, Facebook, because they usually deal with large data sets. But today, this is the problem. Handling the large data sets is the problem with almost all organizations. About 90% of the industry is suffering from this problem. At last, I just passed a bold statement stating that existing methodologies are inadequate in handling the large data sets. Let me share you what are all the existing methodologies and how they are inadequate in handling the large data sets. So let's start with storage. When I talk about storage, I'm sure the first and foremost word which will strike away our mind is nothing but RDBMS. I'm sure of this. When I talk about storage, RDBMS will be the first word where we all think on, which has been ruling the industry from the past 2 decades. Though RDBMS is ruling the industry from the past 2 decades, it has several drawbacks. Where, point 1, RDBMS has a saturation limit, because it cannot give you excellent performance when your data is at the range of hundreds of terabytes or petabytes. You'll experience a degraded performance, point 1. And there is no support for unstructured data. When I talk about the unstructured data, the data on which you cannot define any schema is nothing but the unstructured data. Just like images, video files, audio files, log files, HTML files, XML files, JSON datasets. These all fall under the category of unstructured data, where RDBMS will utterly fail in handling this unstructured data. That's also a problem, because there is no support for unstructured data with RDBMS, which is also a sounding problem with RDBMS. And We know that we usually get the disk space available from SAN, where we usually get the disk space from LUN allocations, logical unit allocations, where the disk will be allocated. Usually the disks will be at 24 TB drive size, 24 terabyte size, and where we have been using FC disks, fiber channel disks, and latest enhancement is of SSDs, solid state drives, which are very expensive, but still we are going for that because we don't have any alternative. So simply, when I talk about data storage on the whole at a simple level, let me talk about the drawbacks like this. Point 1, there is no support for unstructured data. Point 2, it is very expensive because of high-end hardware. These two are the most sounding constraints at the storage part. Most sounding constraints. And after storing the data in the disks, you want to process it, right? Where if you want to process the data sets, the words like ETL, data warehouse, SAP for data management, everything comes into the picture. Where we know that all of these technologies will work with high-end hardware. They require blade servers and Spark processors to work on it, where they are very expensive. But still we are opting for that because we don't have any alternative. And we know that if you want to process the data sets, you need to transfer the data across the network. And so you have the network issues also. And above all, these technologies, whatever I shared you, data warehouse technologies or ETL, each and every tool over here, you need to purchase the license, which is also expensive. So data processing became very expensive because of high-end hardware and the licensing issues. And when I talk about network constraints, because if you want to process the data initially, you need to read the data from the disk and then transfer it across the network, and then you can process it. And at this point of processing the data, transferring the data, you have the drawbacks like this. Using FC cables, fiber channel cables, you can attain a transfer speed of almost 64 Gbps. Excellent transfer speed. But though your network could be able to transfer the data at 64 Gbps speed, disk cannot retrieve the data that much faster. Disk speeds are hardly at 500 Mbps. Just imagine, 64 Gbps and 500 Mbps. Network could transfer at excellent speed, but your disk cannot retrieve that much faster. So hence leading to a speed bottleneck. It was leading to a speed bottleneck, which is a drawback. And we know that we usually use any Unix flavor of operating system at the storage level, where the block size is of 8 KB, 8 KB file system block size, very thin block size. Let's say that you wanted to store 64 MB of data. After all, for storing 64 MB of data, Unix file system will consume 8,000 blocks. And if you want to retrieve the data back, your disk head need to be moved from one block to another block and so on, 8,000 blocks. And the time taken by a disk head to retrieve the data from one block to another block is what we call as disk seek time. That is also a drawback. On the whole, let us talk. On the whole, when I talk about the drawbacks of the existing methodologies, they are just like this. Point 1, there is no support for unstructured data. Point 2, it is very expensive because of high-end hardware and licensing issues. Point 3, the disk seek time. Point 4, network constraints. So we need an alternative, a new technology which will support the unstructured data, which will vanish the disk seek time, which will eradicate the network issues, and that new technology should not be expensive. And that new technology, which had all these features, is nothing but Hadoop. That is nothing but Hadoop. The main reason why I'm addressing much about the data, where I'm stressing much about the data, is over here. I'm sure majority of you might have heard about this organization several times. Majority of you might have heard about this. IDC, International Data Corporation. According to the statistics of IDC, the world's data in the year of 2006 is 0.18 zettabyte. In the span of 5 years, that is in 2011, it increased 10 times and it came to 1.8 zettabyte. Where by the end of 2020, they're expecting this to reach 40 zettabyte. Just imagine, 40 zettabyte. 40 zettabyte is not a simple figure, we know that. Let's make a simple computation. 1 zettabyte equals to 1024 cube terabyte. If you make it approximate, 1 zettabyte equals to 1000 cube terabyte. So 1 zettabyte equals to 10 power 9 terabyte. So simply 40 zettabyte equals to 4 into 10 power 10 terabyte, or 40 into 10 power 9 terabyte of data. This is the data that would come by 2020. How many 24 TB drives do we need in order to store this magnitude of data if you divide it by 24? A huge figure. Not only simply storing it, you need to provide the redundancy also. And how many days do we need in order to process these magnitudes of data, and how many $1 million do we need as the expenses? So the thought itself conveys us that we are choosing a wrong path. We need an alternative. And above all, 80% of this data is gonna be unstructured, where we the people are generating this unstructured data from the social networking sites, where we usually upload images, videos, likes, comments, shares, tags, applications, tweets, charts, posts, whatnot. Will generate huge magnitudes of unstructured data from the social networking sites. From the e-commerce, online reservations, online banking, we usually generate hundreds of TBs of data per day. And we classified mails as semi-structured data, because if you talk about a mail, you'll have to CC, BCC, and from. Where you can define a schema on the mail IDs and you can store it, no problem. But can you define any schema on the text body of the mail? And majority of the mails may have attachment and many may not have attachment, where that attachment might be again unstructured, where the attachment might be an image file, it might be a video file, an audio file, but the mail IDs are structured. So you can store the mail IDs but not anything else. So we classified mails as semi-structured data. Mails are the semi-structured data sets. And even the machine's unstructured data, where the RFID readers, GPS tracers, satellite communications, and the log files, where I'm sure we all know that we usually disable the access log files at the server level. We usually disable that. But if you have the technology to deal with these log files, you can generate money out of this stuff. And this is the place where about 90% of the e-commerce is currently focused on, where we processed the log files of Flipkart, for which we generated 38.6% of the revenue. That is again through Hadoop. And before sharing what exactly Hadoop is, I need to talk about this term, big data. Well, big data is not a technical term actually. Big data is not at all a technical term. Any data having several characteristics could be addressed as big data. And the characteristics that should be possessed by your data sets in order to get addressed as big data are like this: volume, velocity, and variety. Where volume indicates the magnitude of data, whether your data is at the range of hundreds of terabytes, petabytes, exabytes, or even at the range of zettabytes. Huge magnitudes. Variety indicates the type of the data, whether it is structured or unstructured or semi-structured. The type comes under the variety. And velocity indicates the rate at which the data is being generated and the rate at which you need to process that generated data. If your data is of huge magnitudes, which is semi-structured or unstructured, and getting generated at high speeds, you can address your data as big data. It is Hadoop which can handle this big data in an excellent way. But now let me share you what exactly Hadoop is and how it can handle this big data and how it can overcome all the drawbacks what all we discussed earlier. So let me talk like this. Let me share you that whenever I address as Hadoop, Hadoop is always at a cluster level, point 1. Where a cluster is nothing but combination of nodes connected across a network. And a node is nothing but a simple computer. So simply, A cluster is nothing but combination of computers connected across a network. And when you install Hadoop on each and every machine, it will simply become a Hadoop cluster, where after installing Hadoop across the cluster level, it will accumulate two major components, HDFS and MapReduce, where HDFS stands for Hadoop Distributed File System. Well, distributed file system is not new. I'm sure majority of us are aware of that, distributed file system. But Hadoop distributed file system is something new, where the default block size is of 64 MB. Imagine 64 MB is not a simple block size. We all know that. Let's talk like this. Consider you'd like to store 128 MB of data in the Unix file system. After all, for storing 128 MB of data, it will consume 16,000 blocks because the block size is of 8 KB. And if you want to retrieve your data back, your disk head need to be moved across all those 16,000 blocks. The same 128 MB of data in your HDFS will consume only 2 blocks. Where if you want to retrieve that back, your disk head need to be moved from one block to another block, and so on, only to 2 blocks. No need to move across huge number of blocks. So since the block size is of 64 MB, disk seek time got vanished drastically. One of the drawback was no more with Hadoop. Disk seek time was vanished because of the large block size. And since you are storing the data directly in the file system, you have the support to store the unstructured data. Even that was the main reason why we could able to store images or songs or movies on your laptop on our PC, because you are storing them directly in the file system. The same Hadoop also. So let's say that we built a 100 node cluster and we thought of uploading 1 terabyte of file. So your 1 terabyte of file will be broken into 64 MB blocks, and those blocks will be scattered across these 100 nodes. It will be stored across these 100 nodes in a distributed fashion. And if you want to process that, you'll simply design a MapReduce job, where this MapReduce job can be designed either in Java, Ruby, Python, Perl, or even in C++. But since we have majority Java programmers, we usually go for Java MapReduce. That's it. So after storing the data across the cluster, you'll design this simple MapReduce job. So this MapReduce job, nothing but your jar file, will travel towards your data on which node your data is, and it will process the data on all the nodes parallelly. So you're storing the data on the cluster, and you can even process the data also on the same cluster. You're performing both actions, storing and processing, both on the same cluster. So since you are just making storage and processing both on the same cluster, obviously you will not have any network issues, right? And above all, whatever the machines that you are using in this Hadoop cluster are of cheap hardware. Hadoop does not require anything like blade servers or Spark processors. It will require the very minimal basic hardware. Even that was the main reason on tomorrow, actually within 24 hours, exactly in 24 hours, we shall discuss about the cluster building. I shall show you how to install Hadoop on your laptop and on your PC. Because your laptop is a cheap hardware. My laptop is a commodity hardware, and Hadoop works with it, no problem. And Hadoop is an open source. It's not proprietary. So if you observe, point 1, you have the support for unstructured data because you are storing the data directly in the file system. You have the disk seek time got vanished because the block size is of 64 MB. You have the network issues got minimized because you are storing the data and processing the data on the same cluster. And above all, your expenses are drastically reduced because you are using the cheap hardware which costs nothing. And this is what I have been talking about, the data storage and data processing at one hub. That is nothing but Hadoop. And this is the fastest processing ever never made. This is not what Rajiv is boasting about Hadoop. This is IBM's declaration, where we processed 1 terabyte of unstructured data using RDBMS, which consumed 28 hours to process it. The same 1 terabyte of unstructured data using Teradata consumed 6.5 hours to process it. And the same 1 terabyte of unstructured data using Hadoop 180-node cluster consumed 3 minutes 27 seconds to process it. And the same 1 terabyte of unstructured data using the same 180-node Hadoop cluster, but with the latest architecture called as YAN architecture, could make it in 1 minute 19 seconds of time. That too at a cheap cost because of cheap hardware. Imagine about the times: 28 hours, 6.5 hours, 3 minutes 27 seconds, and 1 minute 19 seconds. So this minute performance, excellent performance with that lesser time interval is for Hadoop. And this is what I have been addressing on. If you want to handle your big data, just upload your data. Your data will be broken into 64 MB blocks, where these 64 MB blocks are nothing but your HDFS splits. Hadoop distributed file system will be storing your data in the 64 MB blocks, and it will be storing across your cluster nodes. These are all your nodes, nothing but these boxes are nothing but your computers at the cluster level. So your data was getting stored in a distributed fashion. Here it is. If you could see, your data was getting stored in a distributed fashion. It was stored across the 3 machines. And if you want to process it, design a computation, nothing but a MapReduce job, and it's your MapReduce job which will travel towards the data like this. So you're storing the data on the same cluster, and even you are processing the data also on the same cluster. And if you observe, this is not a simple processing. It's a parallel processing of handling your data sets. If you just delve deeper into this, on each and every node, it will further create several JVM instances, and it will partition the data still more parallelly, and it will process it still more like this. So if you observe, it's not a simple parallel processing. It is a massive parallel processing of handling your data sets. That is what Hadoop is, exactly. That's what Hadoop is. Storing the data and processing the data. So here we got a question. Same copy of data is stored across all nodes. I'll be talking about that, Mr. Vasan. I'll talk about that. We shall discuss how the data will be uploaded into the cluster environment now itself in a much clearer way. Definitely we shall discuss about that in a detailed way. I'm just sharing what exactly Hadoop is here. So you are storing the data and processing the data on the same cluster, that in a massive parallel way. That's what Hadoop is. And then this is the core concept of Hadoop, where it is easier to move the computation rather than moving the data. That's what we have been doing here. Your data is stagnant. If you observe at the cluster level, here on all the nodes, your data is stagnant. You are not moving your data. It's your computation which is getting moved towards the data. That is a massive parallel processing for the ease of handling the data sets. It's not a simple parallel processing. It's a massive parallel approach. And it is easier to deal with small data pieces rather than dealing with big data sets. That's the reason why it went on with a distributed fashion, distributed file system. And above all, it is of cheap hardware which costs nothing. And this is even an important topic to discuss on, where if you see this part, MapReduce, this is the place where the people from any of the programming background, either from Java, Ruby, Python, Perl, or will work. So they require any of the programming background to deal with this area. Definitely it's required. But for the people who are not from any programming background but still want to work on with Hadoop, yes, you have an alternative. You have something called as Hive, which is just similar to SQL. Design your query. That will in turn generate the MapReduce job for you. You need not to design anything else. And you have some other alternative called as Pig, where it has its own scripting like language called as Pig Latin. Whatever the script you design, that will be generating the MapReduce job. You need not to design anything else. And Scoop is a utility tool to import the data from RDBMS to HDFS. Where you're using Scoop, you can import the data from Oracle, MySQL, SQL Server, DB2, even from Teradata, Netezza to HDFS. Scoop will do all the things. And Avro is to deal with serialized data sets, encrypted data sets. It's a rich format of serialization. And HBase is one of the NoSQL database. Where let me talk about this part. NoSQL, the most crazy word. I'm sure majority of you might have heard about this. Where when I talk about NoSQL, the name itself will convey us. NoSQL, not only SQL. Where here it is. You'll not have anything like normalization. No primary keys and no foreign keys. You can store your unstructured data, where your unstructured data will be stored in key value pairs. That is the feature of HBase. And above all, it is not a row-oriented architecture, it's a column-oriented architecture. And you have Zookeeper, the coordination service, which will be installed by default when you install HBase. All these ecosystem components, whatever I addressed so far, are open source. Hadoop itself is open source. But we know that no organization will dare to work with open source, that too with new technology. Because if you want to work on with Hadoop, yeah, here is a question. What is the difference between Hive and NoSQL? Hive is an alternative to design the MapReduce jobs, where Hive is a SQL-like language. It's just like a language which will be acting on the data which was stored in HDFS. NoSQL is something different, where it is for providing the accessibility to the end users for the faster retrievals and for computations. We have almost 150 NoSQL databases over here, where some of them are like HBase, Cassandra, MongoDB, Neo4j, Couchbase DB, Accumulo, Dynamo, Bigtable. So these all fall under the category of NoSQL. Where when I talk about NoSQL, you don't have anything like normalizations. No primary keys and no foreign keys. Everything. There were no more on top of NoSQL. We shall talk about that. We have a separate discussions on NoSQL part, where we shall discuss much more deeper into that area. Please let me know whether am I clear at the introduction part of NoSQL or not. Right. So all these ecosystem components are open source, but we know that no organization will work with open source, will dare to work with open source. Because let's talk like this in a practical way. Let's say that we are trying to make a 100-node cluster. So that I'll just purchase 100 nodes, and I'll download Hadoop from Apache, and I started working with that. I installed Hadoop on each and every machine, and I'm trying to configure it. Meanwhile, while configuring, I have an issue. I cannot expect any support from Apache. And if I want to work with these ecosystem components like Hive, Pig, Scoop, Flume, I need to download them individually, install them, configure them individually. In the meanwhile, if I have any issue, no support. Since this is an open source, you cannot even expect a well-versed user interface on top of this. You don't have any user interface on top of this. So that is the problem with the open source. Owing to these, several organizations came forth where they'll give you an excellent technical support, a very good user interface, and they will offer all these ecosystem components as a package. Where some of them are like this: Cloudera, Hortonworks, IBM Big Insights, Microsoft HD Insights, Astrodata from Teradata, Oracle Big Data, Intel Hadoop. So these all fall under the category of several distributions. But out of all this, Out of all this, the most sounding distributions are like Cloudera, Hortonworks, and even you can hear something like Amazon Web Services, AWS. These are all the most sounding distributions. And here there was a question, Zookeeper. Zookeeper is a coordination service which will be installed by default when you install your HBase. It will just coordinate the architecture of HBase. When it is at the fully distributed mode at the cluster level, then Zookeeper will just monitor the things. It's a coordination service which will be installed when we go on with HBase at the fully distributed mode. Apache Hadoop is nothing but package of all these tools in the ecosystem. No. When I talk about Apache Hadoop, you'll get only these two. You'll get only HDFS and MapReduce. You'll not have anything else. You'll have only these two. You'll have HDFS and you'll have MapReduce. Apart from these two, you'll not have anything. And if you want to work with this, again, this is a separate package where you need to download it from Apache, again install it and configure it. This is also a separate package where you need to download it, install it and configure it. So when I talk about Hadoop, Hadoop will give you only these two, not anything more. But if I talk about any of these distributions like Cloudera or Hortonworks or anything, they'll give you all of them as a package. They'll give you all of them with an excellent technical support, and even they'll give you excellent user interface. Repeat about Zookeeper and Avro. Sure, let's talk. Where? So when I talk about Avro, Avro is a rich format of serialization. Avro is an ecosystem component to deal with the serialization in data sets, encrypted data sets. At that level, Avro will deal. And if you want to encrypt your data, even let's say that your data is very sensitive and you want to encrypt it, so then go for an Avro. Simply opt Avro, and where you can get this data in a serialized way. That is nothing but Avro. And Zookeeper. Zookeeper is a coordination service with the Hadoop, where by default we usually go for the Zookeeper at the fully distributed mode of the HBase, where Zookeeper will be assisting the HBase architecture. In order to run your HBase architecture in an efficient way, we require Zookeeper. Zookeeper know where your data is and all the things. We shall discuss about that. When we talk about Zookeeper, we shall talk about that in a detailed way. Am I clear about Avro? What Avro is? What Avro does? Because Zookeeper, we shall have a special discussion. Yeah, please go ahead, no problem. Encrypted data, in the sense, if you find the data in a serialized way where it is not completely understandable, you cannot understand the things. You cannot understand the things where it is completely serialized. At that situation, you can go for Avro. You can go for Avro, just decrypt it, and then you can just go on. It's a compact, fast, binary data format. Avro will give you this part simply. It's a fast binary data format. When encrypted data gets into HDFS, will it be processed by MapReduce? If you want to process the data sets which were encrypted on HDFS, then you need to use Avro, decrypt it, and then you can perform the actions on top of this. There are nothing like algorithms at the range of Avro. Avro is completely at the range of programming perspective, where it has the schema designing, everything simply like your JSON data sets. It usually handles the data things like it will even handle the things just similar to how can I share it? If you have your data sets in a JSON format which is completely encrypted, and if you want to handle that, simply you can go for Avro. If you want to even customize it, let's say that you want to design your own serialization format, then you can go on with Avro, where we have serialized bytes and deserializing from a byte array. All these things, serializing from a byte array and deserializing from a byte array, everything is possible on top of Avro. And it is actually from the RPC framework, where it has the porting which will be existing for the RPC framework, where you can use Thrift and Java APIs and all those levels. Yes, Avro is for the encrypted data. Avro is basically for the encrypted data. If you want to encrypt the data, go for Avro, and if you want to decrypt the data also, you can go for Avro. Here we have a question. MapReduce won't work for that case. MapReduce, you can make the things, but you need to design a customized input formats at the range of MapReduce, provided if the data is too complex, you need to go for something like customizations on top of MapReduce, where in order to decrease the pressure, you have something like Avro. Then why to struggle that much with MapReduce? Just go for Avro, where you can get the things in a comfortable way other than switching with MapReduce. Because MapReduce is just for the processing, where you can go for customizations, making the things completely complex at that level. But when I talk about Avro, it was already developed tool on top of Hadoop, which is supporting for all your encrypted data sets and all the things. Then why to worry regarding that? Why to just go with MapReduce again? Let's go for Avro. Got to think, am I clear? Right. Let me talk about the part. I hope I'm clear what exactly Hadoop is, what exactly Hadoop ecosystem components are. Now let me talk about the HDFS, the very first ecosystem component, where these are all the basic requisites to move on with the Hadoop area. And whenever we need to work on with the Hadoop environment, we need to install JDK and JRE and Eclipse for the programming. So here is the introduction to big data, where if the data is of few MB, we usually store it in some other spreadsheets or anything else. But if the data is at huge magnitudes, then we'll go for the alternatives, where big data deals with the data of almost 10 power 12 times of the exact actual files, very huge magnitudes of data sets. And here it is. This is the area where the pictorial representation, what usually happens on internet and how the data is getting generated on internet. Where when I talk about Facebook here, per day Facebook usually processes the data of 40 petabytes. When I talk about YouTube, for every 3 minutes, videos which can be produced of 72 hours are getting uploaded for every 3 minutes. And where the data is getting generated from, these are all the different sources, like your people generated data and machines generated data. That's what I shared from the social networking sites and the logs, from the e-commerce, online reservations, online banking. So these are all the different areas where the data is getting generated at huge magnitudes. And we know that why we require data, because data is very valuable that we cannot discard it at any cost. Processing the data sets, we can generate reports, we can analyze it, and we can come for a strategical approaches for the business developments. So that much huge and importance is with the data sets. So we'll never ever delete the data sets. We need the data, and even many organizations will sell their data sets as well. Sell their data sets, and several organizations will even purchase those data sets as well. So data is very much important and we require it. And here it is. Why and who can use this data? The organization that has web server or information of logging, nothing but access log files. It can utilize the logs where you can increase or decrease its costs. Let me talk like this. Let us consider that we are looking for an e-commerce site. Let's say that I just opened a browser and I just typed as ebay.com. I just got an error message specifying that server is too busy, please try after some time. Then definitely I'll just open a new tab. I'll type Flipkart because I want the things to be done in instantly. I don't want to wait for the things. When the server is busy, definitely eBay gonna lose several clients. Several customers will be lost. That's the problem. So they should be in a position to manage the load on the server. So they need to know what is the load and when the load is high, when was the peak load, everything they need to know. For that, they need to opt and process these log files. Access log files should be handled at that level. Here is some of the log files. This is how a log file look like. An access log files example. So as I shared, problem is not with the big data. Problem is how to store, process and analyze this data. That is the problem. That's the main reason why I discussed about the existing storage and processing methodologies just earlier. So before just moving further, let's have a peep through questions. Is Java necessary for working on Hadoop? Java is necessary to work on the area of MapReduce, because MapReduce programming, you can design it either in Java, Ruby, Python, Perl, or even C++. So you need to have the knowledge of any of these programming languages. But since we usually have majority of Java programmers, we usually go for Java. But if you have the knowledge on any other programming languages, as I shared, Ruby, Python, Perl, C++, you can even rock with MapReduce. And to work on with the other ecosystem components like Hive, Pig, no need to know what exactly a Java is, no need to know what a programming language is, no need to know. What would you suggest? We should talk about this later. I have worked on Java, but not much. Oh, if that was the case, that sounds good, Mr. Manas. Because if you have the knowledge of Java, let's say that you require the very basic knowledge like OOPS, exception handling, collection framework, generics, serialization. These are all the topics which are required for the Java to play with Hadoop, especially with MapReduce area. You require all these concepts, only these concepts, nothing more and nothing much. You need not to know what even a servlet is, no need to know that. So let's move on. Here let's talk about a simple use case about the data, where there was a mobile company where it has some expensive plans for their customers. Owing to that, they'd like to target the people who are and who have been working with huge magnitudes of data on internet, who downloaded large data on internet and who are consuming much data on internet. They would like to introduce a new plan for their old customers. and along with that it want to advertise a roaming plan of $100 so that when they are in roaming, no need to switch on to another network. So they don't want their customers or subscribers to move on to another network while roaming, and they want to come up with a new suggestion, with a new recommendation for the plan for their existing users, those who have been working with huge magnitudes of data on internet, those who have been spending much time on internet. So owing to that, they're gonna access the log files and process it enough. That was the target. But the problem here is they have different subscribers in different cities, where each and every subscriber will again go for different plans. So almost all the subscribers are active each day of month because they were using their mobiles almost for 24/7. There is nothing like less load. And the data is getting generated at huge magnitudes, a very large magnitude of data. And here it was mentioned, it's almost a terabytes of information which is getting collected by the organizations at each and every city. And of course, they are discarding it because it is very expensive if you store all such data. But even if you have the technology to deal with those data sets, definitely you can make money out of that. That's the place where you can use Hadoop. So owing to this level, there was a new technology that is nothing but Hadoop, where it got its birth from Apache. From Google, not from Apache. If you observe the history, Google is the sole organization which has been dealing with petabytes of data. Google literally deals with petabytes and hundreds of terabytes of data. And it was $1 million question for all the organizations how Google could be able to manage its huge magnitudes of data. In the year of 2003, so in the year of 2004, Google revealed its secret out to the world, specifying that Google has been following its own file system for the storage, where it built its own file system called as Google's file system. And it revealed that how it has been storing the data across the cluster. The very next year, 2005, it revealed another white paper out specifying how it has been processing the data sets. And these two white papers, Google's file system and Google MapReduce, those two were implemented by a group of people, where it is Mr. Douglas Reed Cutting and Mike Caffarella. These two are the people who acted as the chief for that group, and they emerged these two white papers implementation within an open source search engine project called as Apache Nutch. Apache Nutch is an open source search engine project in which these two white papers were implemented for the first time. And in the year of 2008, the word Hadoop came into the existence, where it was made as an open source currently through Apache, and which is being used widely by several organizations. It's Facebook, Yahoo, not only your social networking sites, but also the e-commerce site. All the things they were using and relying on Hadoop now. And as I showed you, storage part, when I talk about Hadoop is the solution, we just discussed that Hadoop has two major components. It is HDFS and MapReduce. Where when I talk about HDFS, it is exclusively for the storage, where the data will be stored across the cluster in a distributed fashion. And MapReduce is a programmatical approach to process the large data sets. and you have Hive and Pick to analyze them to generate reports and all the things. And when I talk about Hadoop cluster, because I shared you already that Hadoop is at the range of a cluster level. Hadoop will be always at a cluster level. When I talk about a cluster, it is extremely scalable at the Hadoop level. Let's say today we just built a 100 node cluster, and all of a sudden we just came to know that next week we need to increase the cluster size. So no problem. You can keep your services running as it is. You can keep your services running. You need not to shut down them, and you can increase your cluster size like anything. You need to stop your services, and you can keep on increasing your cluster size. Your cluster size might vary from 2 nodes to 20 nodes, 200, 2000, 20,000 nodes. So far, there is no saturation point for that. The world's largest cluster is at Yahoo, comprising of 48,000 nodes. That is the world's largest cluster so far, which is at Yahoo. And the applications for Hadoop, where it is telecommunications, in order to trace out the user behavior, in order to manage the peak load and all that, they usually go for Hadoop, which will be they'll processing their log files, and the recommendation systems, where you can go for Google ads and even at the range of YouTube for the recommendation of videos and all the things. Even currently I have been working with the same project, where we have been working with DirecTV is our client currently, where they'd like to process their user behavior history, their user views, and we need to process it, and we need to generate a report and recommendations for the user behaviors. And at the range of data warehouse also, Hadoop will be an excellent solution in order to handle the web or mobile data sets. Even at the range of predictive analytics for the market research and the forecasting area, simply at the range of, you can say Hadoop is being used at New York Stock Exchange as well. New York Stock Exchange is also using Hadoop, where to predict the trends of the stock market. And Hadoop is not suitable at all the areas. It's only meant for the data which is getting generated at huge magnitudes, and that too for offline analytics. It's not meant for real-time transactions or live processings. It's only meant for analytics. And Hadoop is not suitable for small files, and Hadoop is not for the real-time processing. But of course, latest technology, Storm, will give us the privilege to work with the real-time processing. Storm is also a project, latest project on top of Hadoop, which is giving us the privilege to work on the real-time applications. And this is what I shared. It is not a database, because when I talk about a database, again, I need to talk about the structure and all things. Hadoop is not a database. Yeah, Mr. Wasan, please go on. Please go on with your question. Yes, why Hadoop is not supporting online transactions, right? Because we know when I talk about the transactions, there should be a very fast response, point one. The responsing is very low on top of Hadoop, because there is a specific architecture to retrieve your data back from the file system range. It need to retrieve your data from the file system, because your data was scattered like an unstructured data which is completely scattered across the cluster. It was not a well-versed structured table format. Your data will never ever get stored on top of Hadoop just like that. Point one. Point two, Hadoop has a drawback that whatever the data you upload into the environment, into Hadoop environment, it is write once. You cannot edit that. Let's say that you uploaded a file of 1000 records. You would like to add 1001 record. It is possible. Adding new records is possible. But let's say that you would like to update 15th record. It is not possible. So updations is not possible. Where you don't have anything like ACID properties supported on top of Hadoop, then how can we utilize it for OLTP transactions? You don't have the things on top of Hadoop. That was the main reason. Facebook, YouTube in online, they generate terabyte of data online. Yes, if Hadoop is not suitable, then still we need to have RDBMS. Absolutely. Hadoop cannot replace RDBMS. Hadoop is not an area to replace RDBMS. Hadoop will have its impact at the area of Teradata, data warehouse, ETL, SAP, HANA. At these areas, Hadoop will have its impact. Hadoop will never ever disturb your RDBMS flow. As I said, the latest projects were giving the privileges for you now. Storm, Kafka, they were all trying to make the things supported for these actions. Yes, organizations still have to spend the money for the online transactions. They need to make the things. When I talk about a simple example, we worked with HSBC, where it need to work on with this, with their transactions. For their transactions, the transactions have been getting stored in Oracle. Literally, they have been getting stored in Oracle. And we are using the scoop, whatever I shared, the ecosystem component. We are using scoop to import the data from Oracle to HDFS, then we'll process that. Hadoop will work at that level, not replacing Oracle. It cannot replace Oracle. We'll import the data from Oracle to HDFS and then we'll work on with it. Am I clear? That's what I shared. It's only for analytics. It's not meant for any other things. Hadoop is only meant for analytics. It's completely for analytics. Hadoop is not meant for transactions. It does not have any support for transactions indeed. Let's talk about the storage part, HDFS. Where here is one of the challenge with HDFS, where we shall talk about that. Yeah, Mr. Ajay, please go on. No problem. We shall discuss about the question stuff. Let's talk on with the questions. Let's get them clarified and then we shall just move. Can we automate Hadoop? Yes. You can make the things because you have something like Uzi, a workflow engine, which is used to trigger the jobs on the timely manner. Uzi is it is almost, you'll be designing the Uzi workflow in XML file where you can automize the thing. Let's say that you will be designing a tag. You have something called as coordinators in a Uzi workflow where every 24 hours, if you want to import the data from a specific RDBMS, you can automate that. And for every 24 hours or for every 3 hours, if you want to trigger a job, you can use Uzi. And if you have any issue, if you want to shoot a mail to your email, you can use Uzi. At all these areas, you can automate the process by using Uzi because it's not a manual approach. We'll never ever do the things in a manual way. We'll automate the things. We'll design the shell scripts for Scoop. We'll place it in Uzi and then trigger the jobs. We'll trigger the Uzi job, which will be triggered for every 24 hours and all the things. If you have any issue with the Uzi servers, then we'll try to figure it out. You can use the help of Uzi to make things as an automized. Uzi, actually, the people, they were not discussing. Uzi was not the part of this course actually. In the course curriculum, I think they did not include Uzi, Avro, and Cassandra, MongoDB. They were not included in this course, but if time reps, definitely I'll be sharing you with Uzi. I'll share you that, no problem, not a big deal from my side. Any more questions from anyone? Please let me know. Right, so let's just continue. Let me just discuss this and then I'll just have a break. Let me just discuss this. So there is a problem. So far we discussed that the data is getting generated at high magnitudes on all the areas. If you rely on a single machine, storing the things on a single server, you need to keep on increasing the hard disk storage capacity. One fine day your ports will be completely filled up. You will not find any port to attach external any hard disk. Point one. And you cannot increase the RAM because so far the largest RAM available is of 128 GB. One fine day even that will be exhausted, where you'll fail to get the things in a better way. So you need to look for an alternative where you have the HDFS things like the HDFS architecture. You can store the data across the number of machines at the cluster level in a block level, where your data will be broken into 64 MB blocks, and those blocks will be stored across the cluster environment in a distributed fashion, where it was designed for a file of hundreds of GBs and TBs. Block orientation indicates that, as I said, the default block size is of 64 MB. Whatever the data you upload, that will be broken into 64 MB blocks, and those blocks will be scattered across the cluster. Blocks will be scattered across the cluster. And it has a Unix-like command line interface, because usually when I talk about the Hadoop environment, it was built on top of Linux or Unix operating system. Of course, we have HD Insights also, which is a product from Microsoft, where Microsoft designed Hadoop in .NET, and it tried to deploy it in Windows. But it was not a successful product. It was a failure product, where they are trying to make it out enough. And here it is, write once, which is the constraint, whatever I shared just now. You cannot update the things, but you can retrieve it, and you can even add some more new things. That is possible. It is write once. And commodity hardware, even you have the fault tolerance. We shall discuss about this in a much more detailed way, how it is getting fault tolerance, because whenever I talk about data, fault tolerance is very much important. It should be present. The client should get uninterrupted results. There should not be anything like losing the data. Data loss should never ever happen. Even that is the case with Hadoop. Hadoop will never ever give you the thing like data loss. I shall discuss about that in a detailed way. We shall discuss about that. We shall discuss about the Hadoop architecture, how the file will be uploaded, how the file will be retrieved, everything we shall discuss that in a detailed way. It is not designed for small files, where I shall share you why it is not meant for small files and what happens if you upload the small files. We shall discuss about that as well. Writes are always supported at the end of the file, which indicates you can append the data sets into the environment. Modifications can be made at random offsets of the files. It is write once. This is what I just shared. You cannot update the things, but you can append the things. That is possible. This is even I shared you what low latency of data access, because since you are storing it on the file system area where it is not even in a structured format, and it is literally a huge magnitudes of data, so it will consume much time to retrieve the things. That's the main reason why it is not meant for analytics and all things. What are offsets? Offsets indicates the middle of the files, in between, a different area at random level, in the middle of the things. So here it is. It's just like, yes, in between. Not for the codes actually. It is not for the codes. Offset indicates it's just like a byte offset, where the bytes in between the bytes in the middle of your data. Let me share you. This is the offset. If I make the things, if I just change, want to change the things, this is the offset. This is the offset in middle of the things, not at the end or not at the beginning. In between, in middle, at the random level. That is nothing but the offset. It's a byte offset. So HDFS, am I clear enough? I don't see the name actually. I forgot. I think Mr. Manas. Am I clear enough? What an offset is simply? All right. Oh, fine. Okay. So let's move on. Yeah. Fine. Okay. I heard the response now. I could see that, Mr. Manas. Okay, fine. Thank you. So let's move on. Enough. HDFS is designed for the files where the files will be broken into typically 64 MB. Of course, you can modify it actually. When I talk about the Cloudera machine, at the practical area, we are not using, we'll never ever use Apache. Not only we, any organization will never ever use Apache. They'll go for any of the distribution, but most probably most sounding distribution is Cloudera, where the default block size is of 128 MB. It is not of 64 MB at the Cloudera part. Point one. And the latest CDH5, the latest enhancement, they are just making it at 256 MB, because larger the block size, better the disk seek, faster the response. And so the data will be stored across the cluster, across the nodes in the machine, and then it will be retrieved by. Here it was addressed as data nodes, where I shall share what exactly a data node is and how exact the architecture of Hadoop look like. I shall delve into that. We shall start up with that journey.